Today we are going to see the block diagram reduction technique. So last class we have seen the transfer function for the physical system. So if directly the physical system is given, how to find out the transfer function we have seen. So there some difficulty is there. If the given physical system is complicated, by using a previous method it is not easy to find out the transfer function. So that is why we are going to the next method by which we can able to find out the transfer function even the given system is complicated. For example, in the last reduction technique, so we had maximum of 3 masses or 3 moment of inertia in a mechanical system. So we can easily find out the transfer function. If it is more than 3 mass or moment of inertia, so it is little bit tedious to find out the transfer function of the given system. So for that we are going for next improved version of method is block diagram reduction method. So in this C of S, near to the C of S, you are taking a signal, that is in the output you are taking some value, that is B of S you are taking from the output, and that is given as an input to the summing point. So this is called as, that point where you are taking from the output is called as a takeoff point. Again next one, forward path. So forward path is nothing but the direction of flow of signal from input to output, that is from the left hand side to right hand side if the signal is flowing, or you can say it is from input to output the signal is flowing, is called as a forward path. And next path is a feedback path. It is a path from output to input. So you can define it as the direction of flow of signal from output to input. So these are the different notations we are using in a signal flow graph. So use notations. Here we are having certain rules which is applicable to block diagram reduction technique to reduce the given block into a single block and to find out the transfer function of the given block diagram. So here you are having different rules. The first rule, if you see, you are having 2 blocks which is connected in series. So you can say the cascading of 2 blocks, that is both are connected in series. So if you see the overall transfer function of this 2 G1 and G2 is, so you can have inside the block single block G1 and G2. So if it is connected in series, you have to multiply the gain. That is the first rule. Again, if you are saying a second rule, blocks in parallel. So all the 3 blocks here you are having, all are connected in parallel. Parallel in the sense all the signals are flowing in all the blocks from input to output. So you can say that all the 3 blocks are connected in parallel. So if it is connected in parallel, if you are finding out the overall transfer function, it is nothing but addition of all the 3 parallel path gains, that is G1 plus G2 plus G3. So this is for when you are having blocks are connected in parallel. And next one is elimination of feedback loop. So if you are saying an elimination of the feedback loop, you are having a forward path and also you are having a feedback path. So you have to combine both the blocks and then you have to find out the transfer function. So here 2 possible things are there. Accordingly your final gains are changing. So one is you are giving a feedback gain H1 to the summing point as a negative value, that is the first block. And second, you are having an H1 which is given to the summing point as a positive value. If you are giving H1 to the summing point as a negative value, you will be getting overall gain as G divided by 1 plus G into H. If you are giving an H1 to the summing point as positive, you are getting an overall transfer function as G divided by 1 minus G1 G into H1. So here depending upon whether you are giving an h1 as positive or h1 as a negative, your denominator is either negative or positive. It is in the opposite signal. So this is to find out the overall transfer function of the given system when you are having a system with forward path and feedback path. And the next rule is, so associate law of summing point. So if you are having a summing point, using that summing point, how do you find out the overall gain of the system? So here you are having G1 and here you are having two summing points. One is having an input of x1, x2, other one is having a summing point, the last, that is after the block you are having a summing point as x1. So here your output is y, after y you are having a summing point. So first you have to find out for y. So to this G1 block you are having two inputs, both are positive inputs, that is x1 and x2. So both x1 plus x2 is given as an input to G1. So your gain y is nothing but G into x1 plus x2, and this y is again given to another summing point, and another summing point is having an input of x1, and here x1 is a minus x1. So your overall transfer function is x1 plus x2 into G1 minus x1. Okay, and this is an overall gain of this particular rules 4 block diagram. And rule 5 is shifting a summing block before the block. So here summing point you have to shift before the block. Block is nothing but before G1 you have to shift it. Actual system you are having this summing point after the block. So now you want to move before the block. So wherever you are moving a summing point, ultimately your output x2 should not get changed. In that way you have to move it. So you have to find out at present condition what is your x2. So if you are saying an x2, so here to this block G1 you are giving an input as x1. So output of the block is G1 into x1. So this G1 into x1 is given to the summing point with a positive value, and you are having another input to the summing point is an x2. Then if you are finding out the overall output x2 is equal to x1 G1 plus or minus x2. So that is your output. But even when you are moving the summing point before the block, you have to maintain the same output. So for that what you have to do is, so here you are having an, while giving a second summer, that is a summing point after the block, if you are having a summing point, if you have to now move to the before summing point, you have to have the same output. So after the summing point you are not having any G value which is added, but before summing point you will be having a, if you are moving a summing point before the G1, G1 is also added. So you have to eliminate G1. So you have to have a block with 1 by G. So automatically this G1, that block effect which is added to the summing point, will be eliminated, and you will be having a that is an modified diagram, that is by moving a summing point before the block you will be having like this. Okay, in the second column what is given, that is a form you can able to have it. Similarly you can move the summing point. It's a sixth rule. If you see, you are having a summing point before the block. Now you have to move after the block. So if you are having a summing point before the block, so you will have an effect of G. But while moving after the block, that is G, so G effect will not be there. So in a summing point you have to include the value of G with the existing input. Similarly, rule 7, you have to move the, similar to the summing point, you have to move the takeoff point already it is after the block, you have to move before the block. So when you are moving before the block, you have to include G, because if it is after the block, the effect of G is in there, but while moving and takeoff point before the point, the effect of G is not there, so you have to add the block with G. Similarly, if you are having a takeoff point before the block and if you want to move after the block, so you should not have an effect of G, so you have to eliminate it. So you have to have a block with 1 by G. So like this, while moving either summing point or takeoff point before the block or after the block, you have to include the block. It may consider G or it may consider 1 by G. That is, you have to include G or you have to eliminate G. So like that, while moving, you have to consider these rules and then you have to put it in your block diagram, and then you have to reduce the block to find out the overall transfer function. So these are the some of the rules we are using, and these are the most commonly used rules also in a block diagram reduction technique to find out the overall transfer function of the given block. So this is one of the example of our block diagram reduction technique. So here, just like that, you cannot able to solve the problem, because this problem is not similar to the rules which we are having. For example, if you want to combine G2 and G3, you cannot simplify. Both are connected in cascade means not, because in between you are having a takeoff point, you are taking an H1 from there. So you have to move this takeoff point either before G2 or after G3. So whichever is convenient, you can move it. It's not a constant rule that you have to move only before G2 or only after G3. So if you are moving before G2, again further reduction is also very simple. So I can move this H1 before G2. So when I am moving H1 before G2, I have to include the block which consisting of G2, because actual system, while I am taking H1, the effect of G2 is there, but when I am moving this takeoff point before G2, effect of G2 is not there. So with the H1, I have to have another block which is having an value of G2. Then once it is moved, you can combine G2, G3, and again you can combine G4. Okay, so after that, the summing point, the third summing point will be removed. Then again you can have a simplified diagram, and you can able to simplify the whole system, and then you can able to find out the overall transfer function. Here the main point is, first you have to identify which point should be shifted. That is very, very important. Here I set the point between G2 and G3. You may ask the question, why can't you change G4? So before G2 you are having a G4 takeoff point. Why don't you move? So you can move it, nothing wrong it. You can move G4 takeoff point after G2, and then you can combine G4 and G3. Okay, so anything can be done according to your convenience. You can do it according to the rules and regulation. You have to move it. That is very, very important. So this is how, using your rules, you have to reduce your block diagram, and then you have to find out the overall transfer function of the system. Here the overall transfer function of the system is C of S by R of S. You have to find out. So this is how you have to use the rules and regulation of block diagram reduction in a block diagram to find out the overall transfer. Thank you.